Welcome to today's lesson on polynomial and rational inequalities. I have the word inequality highlighted to be sure you understand that an inequality will involve the symbols of less than and greater than. I will begin this lesson by scrolling down to topic 4. Topic 4 is showing equations in which they are equal to 0. And when you solve a rational equation, noting that a rational is a fraction involving a lot of variables, you want your equation to be set equal to 0. Number 9 and 10 is set up equal to 0, but number 11 is not. It is equal to 1. We need to fix this and rewrite it so that it is compared to 0. In order to do this, I need to subtract 1 from each side of this rational equation. Now I've left a lot of space next to my 1 because I'm going to need to come in here and get a common denominator so I can actually collect the fraction with the whole number 1. I need the new denominator of 9x plus 2. It is a good idea to put this new denominator in a colored pen. I believe it makes it much easier to see how that gives you the new denominator of 9x plus 2. Now I can add my numerators, which would be 4 and distributing the negative 1 minus 9x minus 2. Simplifying the numerator, I get one fraction or one rational equal to 0. To solve this, some students just set the numerator equal to 0, which is fine. Or an alternate method, which is also fine, would be to make the 0 a fraction, placing it over 1, and cross multiply. Whichever method you use, you will still result in a negative 9x plus 2 equaling 0. Now to continue solving, you would subtract the 2 and divide by the 9. This is my solution. Now, anytime you have a rational or a fraction, you must always be observant of the denominator of the fraction, noting it can never equal 0. In other words, my x value can never be a negative 2/9. Had my result, which I squared off in this box, been a negative 2/9, I would have said there were no solutions. Now let's move on to the next page, specifically number 14, which again has a rational in it, but now take note, we're looking at an inequality instead of an equation. This has the less than or equal sign. We are asked to fill out this large table, and the first column has intervals in it. So let me explain where these intervals come from. Just as with the equation, I need to add the fraction to the 6, but in order to do this, I must get a common denominator of x minus 2. With this new denominator of x minus 2, I can add the numerators, which would result in a 6x plus 11 as my new numerator. Now with my rational inequality, I need to come up with what is known as critical values. These are the values which create the intervals in the table. I find the critical values by setting the numerator equal to 0 and the denominator equal to 0. These two values I place on a number line, making sure the smaller number is on the left side. I now have three regions on my number line. The leftmost region are all numbers between a negative infinity and a negative 11/6. The middle region is all numbers between a negative 11/6 and 2. And the third region is between 2 and positive infinity. Those intervals are listed in this table. The second column in the table is asking for an x value in the interval. My leftmost interval is to the left of a negative 11/6, and a negative 10 is a very easy number to use. Between a negative 11/6 and 2, an easy number would be 0, and between 2 and infinity, the number 10. Tens, ones, and zeros are most common x values to select from your intervals, because you will take these values and then substitute them into the inequality. So in each column, or in this column, first row, I'm replacing my x value with a negative 10 right here, as you see highlighted. So I go to my original inequality and I replace the x with my test value of negative 10. When I do that, my result is a positive 49/12. In row 2, I'm placing my test value of 0 in, and in row 3, my test value of 10. Returning to my inequality, the goal is to determine if my numbers are less than or equal to 0. In my first example, 49/12 is not less than or equal to 0, resulting in a false statement. In the second row, my negative 11/2 is less than or equal to 0, which results in a true statement. And in the third column, my result of a positive 71/2 is not less than or equal to 0, resulting in a false statement. This completes the table. Well, in the near future, you're not just going to complete a table, but you're going to be actually solving this inequality, meaning you're asked to find solutions. Your solutions occur where you have a true statement. Your true statement is in row 2. Your solutions will be in interval notation because you will have numerous values which will give a true result. So your solution is the interval in row 2, all numbers between a negative 11/6 and 2. Now this interval has parentheses on it. However, your original question or your original rational inequality states less than or equal to 0. The equality portion of the inequality states that you can use the numbers on the ends of the interval, meaning the negative 11/6 and the 2 are part of the solution set, and we would therefore put a square bracket on each of these numbers, and those would be the solutions to the given rational inequality. Let's move forward and also look at number 16. If you look back, number 16 is the same as number 13, but this time they're referring to a graph in this question. You will need to create a table of values to answer this question. So again, I'm going to show you how to get the critical numbers. The critical numbers would be found by setting each one of the factors in the inequality equal to 0, resulting in the value of 0, 2, and negative 3. These are the 3 critical values which we would place on our number line, being sure to order them from small to large. In this example, we have 4 regions. The leftmost region is negative infinity to negative 3. And you can see my interval notation for each of these 3 regions. These 4 intervals are written in the table on the far left column. Now I need test values in each of these regions or within each of these intervals. Remember, the best numbers to use are tens, ones, and zeros. So to the left of -3, I would pick -10. Then I would try a -1, a +1, and a +10. These are the x values written in column 2. Now I would take each of those x values and plug them into my inequality, getting the results as you see in column 2. Column 3 says, is this point above or below the x-axis? Let me write the point. In row 1, the point is an x value of -10 and a y value of a -840. Now when I plot this on the graph, you can see that -10 is really not fitting on this graph. So I kind of spliced it a little bit where I have it highlighted so I could force that point on the line. So you can see that the point -10, -840 is definitely below the x-axis, which is why I wrote below the x-axis. The same holds true for each of these columns. The next point is -1, +6, which when plotted on the graph is above the x-axis. The third point would be the point 1, -4, which when plotted on the graph is below the x-axis. And I may have mistaken, I don't know how I pronounced it, but the second column, the second row, it was above the x-axis. And the last point, 10, 1040, when you plot it off of the scale of the graph, you will take note that it is above the x-axis. Therefore, in the last column it says, does the x value make the inequality true or not? Going back to the fact that the inequality, let me point to it, in this square up here, the inequality is greater than or equal to 0. You can see that -840 is not greater than or equal to 0, which is a false result. Again, the future is going to ask you to solve the inequality, and therefore you're searching for solutions. Your solutions occur where you get a true statement. You get true results in row 2 and row 4, which are the inequalities -3 to 0 and 2 to infinity. We put a U shape between them representing the union of those two intervals. Again, if I write my original inequality, it asks for greater than or equal to 0. The equal portion means I get to include the end values of each of my intervals. Placing square brackets on these numbers in interval notation rather than a parentheses. Remember, you cannot put a square bracket on infinity because infinity is not a number. Looking now to the connection to college algebra on number 1, this is also referring to a given graph. Recall that f of x is just a y value. So in part A, it's really asking where is y greater than 0. Well, when you consider points on the grid, the y value of every point is positive if you are above the x-axis. I'm going to highlight everywhere we are above the x-axis with this graph. It would be to the right of 2 and to the left of -4. taking note that this graph does continue on each side. So, in interval notation, the y value is greater than 0 to the left of -4, or negative infinity to -4, and to the right of 2, which would be written as 2 to infinity. In part B, it is asking where y is greater than or equal to 0, which is above the x-axis or on the x-axis, which means you may include the numbers -4 and 2. Therefore, this would be negative infinity to -4 with a square bracket on the -4, and then from 2 to infinity, including the 2. It now asks in part C for y values less than 0. Well, the y-coordinate of the point will always be negative if it is less than 0 when you're below the x-axis. Therefore, as I highlight this region, it occurs between -4 and 2 that my graph is under the x-axis. This interval notation to represent this region would be from -4 to +2. In part D, it says below or on the x-axis when you have a less than or equal to in your inequality. Therefore, once again, as in part B, I would use a square bracket for the less than or equal to inequality. This will end this recording, and I ask that you go back and look at the filled notes on this entire lesson to try to solidify your understanding of this material. I hope you have a great day.